Okay, so we're getting to the last set of scripts, and that will end things. So the next set of scripts is we talked about the C-board controller, and the C-board controller has a C-board buttons script that you're looking at, and as you can see, it looks very similar to the other button scripts. We're looking for a game object, in this case, it's board controller. Because it has to talk with board controller, I'm just using the on mouse down and the on touch begin, and I'm calling process request. All the button scripts will look just like this. And like I said, the reason for that is it gives us a form of encapsulation. And later on, if I decide to do something with button up, mouse button, mouse click up, swipe, pinch, down, and so forth, I can do those things for the particular scene without having to worry about interrupting any other scenes, because the script is pretty lightweight. So it's actually worth more making individual copies of it than to try to use one to share it and then have problems down the road. All right. So, and as you can see, this is only talking about the game buttons, and those were the reset and done buttons. So as you can see, this calls process request. Okay, and then this goes down in the bottom and it calls the C board, calls process request. And when we go to the C board controller and we look at process request, you'll see that it just is a switch statement, plays the audio click, switch statement says load game level. Okay, this is for reset. Essentially loads the level again. That automatically initializes all the variables, and it's as if we went in for the first time. So we don't have to worry about cleanup because the system does all the cleanup for us. And the other one is done, which goes to return home, and return home we just saw waits a moment to let everything stop playing and so forth and synchronizes, and then loads the home and everything's initialized. All right, so let's look at level controller. That's the main routine that handles the modifying of the levels and stores it into the player preferences by so that they can be saved later on. All right, so as you can see, as the start comes in, the first thing it does is that it reads the player preferences, so it can display it on the screen to say this is what's selected. And then in the process request, which is what's called by the selection of a button, it determines the parameter passed in this case, it's which button has been pressed. And if it's easy, it'll set everything up for easy and then do the save of the preferences. If it's hard, it'll set up everything for hard and save the preferences. And if it's a done button, it just does nothing and loads the home level. That's pretty much it. This type of the configuration part is relatively simple, but it is an important part. And so we can look at the level buttons, and as you can see, it looks like everything else. The only thing that's different is the button type and the controller. In this case, it's level controller. All right, so that's that. Let's look at the C mode controller, and it's exactly like the level controller. The only thing is that we're dealing with the mode, which in this case is either the bot or the human, and we return. So it's the same structure, it's just different information. Again, the mode button, same format, it just looks at the mode controller. Okay, then there's the player controller, same idea. As you can see, the player controller takes care of the firing of the, well, okay, take it back. The player controller is a little different than the setup of the other one. So we've taken care of all the setups. The player controller is the script that's attached to the vessels, the spaceships, Goombats ships, and the human ships. Okay? And as you can see, it needs to know the speed of the ship, the rate at which the laser fires, where is the actual laser, and where do you want the laser to come out of, because they're different from ship. As you can see, the ships are different. The human ship is different from Goombat's ship. So you want to make sure that the shot emanates from an appropriate position so that it doesn't look like it just came out of thin air, or the shot came from within the ship. Okay? So again, the firing of the laser, since it's continuous, it has to be in a while loop, a continuous loop, initiating shots, and I have to wait a certain amount of time or else the shots don't look right. So if I have to wait, I have to do a start coroutine, and I have to block, so all the other events occur, and that's pretty much what the player script does. So it just continuously fires the laser. And now notice, because this doesn't need any of the constants, it derives directly from mono behavior instead of deriving from the constants, because it doesn't care about them. Okay? So let's see. So then we have player button. Okay, this is where the player option controller, same idea, you play who goes first, which player goes first. Okay, and that would be this script, as you can see, looks just like all the other scripts to set the properties. Then we already looked at the C common constants, and we looked at the button logic. So let's see what's left. There's the random rotator. This script is used for the asteroid. As you can see, it's taking the angular velocity of the rigid body and it's causing it to rotate in some direction. The random method that we're using is inside unit sphere, which means this is loading all the rotation information in a random fashion rather than just a discrete number between 0 and so forth. And then we multiply that value by a tumble speed, and that's how we know how fast we want the asteroid to turn. Okay, so these two numbers together cause the angular velocity of the asteroid, as you can see, in a random fashion. Okay. Asteroid selection, as you can see, is the same as anything else because we're treating the asteroids like buttons. And this one's a little different because, this is calling the start coroutine process request. And this one's a little different because what it has to do is that it's preventing the user from pressing a selection too soon. Okay, so and then it attaches to the board and it decides which play mode it's in, whose turn it is, and the determination is made to select the process selection. Remember we said it goes to process selection for the human, and then from there it goes to a human move. All right. Destroy on boundary. This was the script that was attached to the boundary collider. As you can see on exit, it says that if the thing that penetrated itself, that's the collector, that's the other, that entered its sphere. It says if it's not a laser bolt, then set animation to false, which means the ship, that it was a ship. And this is where the scenario ended and the game object goes away. If it is a laser bolt, it just destroys the laser bolt because there are going to be several laser bolts being fired. Okay. Then there's the destroy on contact, which uses the on trigger enter instead of the on trigger exit. And what it does is that first, when the item appears, you'll see we're checking to make sure that it's not in the boundary. Well, because the laser bolt is created within a boundary, the effect is that the boundary thinks, the laser bolt thinks that something has entered its sphere, which is the boundary. Okay? So what it tries to do is that it immediately thinks it has to explode. It has to destroy itself. So as soon as the laser bolt appears, it'll be destroyed. And we want to prevent that. So as soon as we realize that the other target that penetrated the laser bolt sphere was the boundary, then the ship shows up accordingly. And this also gets attached to the asteroids, and it also gets attached to all the ships, because as they're created within the boundary, you don't want them to destroy themselves. So if it is the boundary, then it'll just be ignored. If it isn't the boundary, then it knows it was something else, and it does destroy itself. Okay. The other script that we have was the determine character mark. This script is attached to the text in the mark plaque that shows up. So this is how we determine whether to put a 0 or an X when it's played. That way we don't have to worry about it, and it keeps things sort of encapsulated. So I don't have to make calls to this routine. The box appears, the panel appears, and then this script is launched on startup, on the start event, and what it does is that it goes out, reads whose turn it is, and then it determines by the whose turn it is which one to put an X or a 0 in the block. Okay, so if it was player number 2's turn, it would get a 0. If it's player number 1's turn, it would get an X. If it was Goomba's turn, it would get a 0. So the system tracks that for us, so we don't have to worry about it. That's why it's done in this fashion. Let's see. The mover script. This is the script that's used to move the ships. And it's also used for the lasers, laser bolts. So, because the rigid body has a velocity, and we're telling the transform in the forward direction, we're taking that value and multiplying it by a speed. And that speed is public, so it's coming in from one of the properties on the side of the editor, and that will determine how fast the ship goes. Now, the interesting thing is that what I noticed is you would think that the speed would be the same for all the ships within the columns and the rows, and it's not. It must be some artifact of the physics engine dealing with some aspect ratios. I'm guessing. I'm taking an educated guess, but the human ships I had to do 3 seconds, where the Goombot ships I had to do 4 seconds. So I don't understand why, but like I say, I'm taking an educated guess that I think it has something to do with some relationship of how the physics engine interacts with the rendering of the object in the pixel world. So because of aspect ratios and pixels per inch are not the same, horizontal and vertical, that the perception is that the ship moves faster in one direction, moves faster vertically, and it moves faster horizontally than it moves vertically. So that's why I had to increase the speed on the Goombot ships, because they're going vertically. Again, this is just a guess, but it was something that I noticed, and I figured I'd mention it because it was cool. All right, let's see, what else do we have? I believe we covered everything. So, we're back here. Let's go to the home screen again. And pretty much done. That's it. Thank you for your time. Again, this is the Tic Tac Toe game that I did for my Mobile Game Masters Program class. It's available online. These videos are going to be posted to YouTube. They'll be under my name, Paul Cefalu, if you want to watch them further or tell your friends and so forth. It was pretty cool. I mean, I was really amazed at how much work was involved in just something as simple as a tic-tac-toe game. I mean, any one piece was not that difficult or impossible, but there were so many parts and so many components that worked together. So there was a debugging issue of interaction. Everything had to be tested out. You had to walk through all the scenes. There were a lot of parts, looking at a lot of parameters and information to determine what to do. So that took a lot of time and effort. But now the approach I took here is that because I broke up design in terms of aesthetics and game mechanics, configuration in the AI. Now the idea, in theory, and hopefully it'll work in practice. I won't know till I actually try to do it, but it should make my life a lot easier going forward because the assets are created such that they look like components for aesthetics rather than just assets that are part of a game. So they're separate. The game mechanics is also separate. So this doesn't have to be a tic-tac-toe game. I mean, at this point, the way the game operates, all I have to do is change the AI, and it essentially becomes a different game because the user is going to play the game based on the rules, and the AI makes its decisions based on other rules. So this could be a card game. This could be of any type of game that could be checkers. It could be any of that. It's just how I set up the rules and the game mechanics and the strategy, and the assets are all set. It'll just be the game board, which is which would be the game scene. Okay, as we load that, instead of seeing a tic-tac-toe board, what you would see is a checkerboard or a chessboard. And the individual components can be pieces. So rather than seeing ships or asteroids, they can actually be pieces on the board. And so you can move them around. So, I could have different types of objects, and then I could still have ships flying across the screen, blowing up my assets that are on the on the screen and so forth, and so it's like I say, it's I think it was worth the effort. It was a lot of work. Had to be done in a short period of time, along with other things, and of course, then there's life you got to deal with. But I had a good time. I hope you enjoyed it too. Okay, and that's tic-tac-toe. Thank you.